In business, the solving of systems of inequalities is often used, particularly as an example if a business is trying to determine, what might yield the maximum profit or what might deliver the minimum cost given constraints, and they can address that by solving systems of inequalities. And linear programming is a method that is used to determine minimum and maximum values of a function. And once you determine a feasible region, which is what the solution to the system of inequalities would represent, the vertices, I should say, of that. You get those vertices, then you can plug those coordinates, the x and y coordinates, into a function and determine maximum and minimum values. Now let's look at what we got right here. So we've got a system of linear inequalities where -6 is less than or equal to y, and y is also less than or equal to -2. And then we've got some linear inequalities where we got y is less than or equal to -x plus 2, and y is less than or equal to 2x plus 2. And we would graph what amounts to these four inequalities and determine where the vertices are, and then we take the coordinates of those vertices and we plug those into this function right here, function of x and y, and determine which one of those vertices gives us a maximum or a minimum value. Now, I graphed these in GeoGebra, and I graphed these as equalities, not inequalities, so it wouldn't get quite so messy and hard to determine where the feasible region is. So let's go take a look at that and determine, and we're going to find the vertices, and then we are going to plug those into this function of x and y and determine maximum and minimum values. So here we are on the graph, and you can see that we graphed y equals -6. Remember, y is less than -6. And so let's see, that would include this region here. And y is greater than -2, and so that would include this region here. And then we've got y is, what was it, less than -x plus 2, which is this green line coming through here. And if I were to plug in a test point for that, 0, 0, is 0 less than 2. If I substitute 0, 0 for x and y, and that would be true, so I'd be shading towards the origin, not away from it, on the side that would contain the origin. And then we had y is less than or equal to 2x plus 2, which is this purple line. And let's see if I did a test point on that. 0, 0 is y less than or equal to 2. That would be true, and so we'd be shading here. And you can see I've already shaded this area in I don't know what color that is. Anyway, it's not white. So let's see where the vertices are. Now I got one here at point A, and that is when x is -4, 1, 2, 3, 4, y is -6. So I've got a vertices at -4, -6. I've got one right here where x is -2, y is -2. So I got a -2, -2. And then here on the right side of this, when x is 4, y is -2. And down here, when x is 8, coming straight down through here, y is -6. So I have found my vertices, and now we're going to substitute that in each of those 4 vertices into the function fxy equals 6x plus 4y. All right, let's use this right here first. So let's say that if I had 6 times negative 4 plus 4 times negative 6. Let's see, 6 times negative 4 is negative 24, and 4 times negative 6 is negative 24. So we got negative 24, or negative 48. And so that would be one value. Let's now use this coordinate 2, 2. So we'd have 6 times negative 2 plus 4 times negative 2. And 6 times negative 2 is negative 12. And 4 times negative 2 is negative 8. And so that's going to equal negative 20. And then we're going to use this coordinate 4, 2. So 6 times 4 plus 4 times negative 2. And 6 times 4 is 24, and 4 times negative 2 is negative 8. So that equals 16. And then lastly, we're going to use this coordinate 8, negative 6. And so we've got 6 times 8 plus 4 times negative 6. So we got 48 minus 24, which equals 24. All right, now I'm trying to determine, okay, well, what's my minimum and my maximum values? Well, let's see. Well, obviously my minimum is this one right here, this coordinate right here, where x is negative 4 and y is negative 6, because that gave me negative 48. This one was negative 20. And I got 16 and 24 over here on the positive side of the x-axis. And so my maximum then is this coordinate here, 8, negative 6. So then I can express my answer as I'm at a minimum of where x is negative 4, y is negative 6, which equals negative 48. And I have a maximum where x is 8 and y is negative 6, which gives me 24. And those would represent the minimum and maximum values for the bounded region. And we call it a bounded region because we can enclose this polygon with where our vertices all come together. Next up, we'll look at an unbounded region.